Okay, this is the last of the videos. This video is going to go over some of the types of problems that you had back in the first semester. The types of problems that I would expect you still to know at this point in the year, and the types of problems that you're going to have to be expecting to know even in geometry next year, but definitely when Algebra 2 starts off 2 years from now. So the first one here, number 7, I've rewritten out here in blue. And what you've got here is a case where x's are on both sides, and you've been asked to solve the equation. Well, solve the equation means tell us what the missing information is. Solve the problem. And the problem is that we don't know what x is. There goes Mrs. Branley. I'm going to close that door. Hang on. Okay, now I'm back. I was saying that the problem or the challenge is that we've got x's on both sides. Got to get the x's together so we can figure out what x is. So if I were you, I would move the x's together so that they're away from the number that doesn't have an x, the constant over here. So I'm going to move that 4x over and out of the way. And since it was a negative, I'm going to add it to cancel it out. Those go away now, and I've got to do the same to both sides. So this side also has 4x added to it. That means together these add up to make negative 3x. These canceled like I wanted them to, so now I've got negative 3x equals negative 27. To figure out what x is, I've got to move the negative 3 over. I'm multiplying by negative 3 right now, so I've got to undo the multiplication, which means I divide by negative 3. I do that on both sides. And now on the left side, that's going to cancel out. I'll just have x. And on the right side, I've got negative 27 divided by negative 3, which is 9. I can always double check by plugging this answer, x, back into the equation and making sure it works. And sure enough, negative 7 times 9 is negative 3. Negative 4 times 9 is negative 36. Negative 36 and negative 27 make negative 63 on this side. So negative 63 equals negative 63, which means x is 9. Let's move on to the next problem. This time I asked you to do number 13. It's got more steps, so it's a slightly more crowded slide here. I've rewritten it out here. And the first thing I've got to do is distribute. It's kind of obvious on the right side that I've got to distribute that 5, but you should also realize on the left side I've got to distribute that negative sign. So I'm distributing that negative to the 11, but also to the negative 2. If you don't do that, then when you take it out of parens, you're going to say it's negative 11 minus 2x. It's not. It's negative 11 plus 2x. Anybody who ended up with negative 11 minus 2x here is making that mistake that I'm talking about. Also, you got to distribute the 5 to both, so I've got 5x plus 40. Now I've got to get the x's together. Well, when I've got this kind of choice, I might as well move them in a way that I'm going to still have positive x's. I'd rather not have to deal with negatives if I don't have to. So I'm going to move the 2x over. And if I subtract 2x from both sides, then I have what I wanted. I've got a positive x here. I've got 3x, still had 40, and still have negative 11. So now it's negative 11 equals 3x plus 40. Well, I want to know what x is. Got to move the 40 over. So I subtract that away from both sides. The right side I'll now just have 3x. But on the left side, I'm now going to have, and I know my handwriting is hard to read with this pen, 3x equals negative 51. Well, if I had a problem like this on my test, I would certainly allow you to use a calculator. I'm not going to be asking you to do negative 51 divided by 3 by hand. So don't worry if you came to this problem and said, wait, I don't know how to do this without a calculator. So I'm going to divide the 3 away from both sides, and x is going to turn out to be negative 17. If you've done the problem and you're not sure that negative 17 is the right answer, once again, you can plug negative 17 in for x on both sides, in both places where there's an x. Let's move on to the next problem. This time I'm going to work out number 8 here. I've rewritten it here. Once again, I've got x's on both sides, and when I just have the one constant, like I do here, I'd rather move the x's together away from the constant. So I add the 4x to both sides. That means I'm going to have 2x on the left. It means these will cancel, and I'll still have 24 on the right. So now I've got 2x equals 24. I only want to know what x is, not 2x, so I divide the 2 away. Those will cancel. On the left I'll have x, and on the right 12. I can always check by plugging it back in. Put 12 in for x here, put 12 in for x there, and you'll find that the two sides are equal to each other. Which leaves us with one last problem, number 15 here. This is another case of double distribution. I've got negative on the outside of these parens, and I've got 3 on the outside of those. So like before, I'm going to distribute them. So on the left, I'm going to have negative 10 plus x, and on the right, I'm going to have 3x plus 12. All right, I want to move the x's together to one side or the other. I'd rather move them in a way that I'm going to end up with positive x's. I'm going to have constants on both sides, so I could go in either direction. Those cancel. The right side will just be 2x now, and everything else will be left. So I've got negative 10 equals 2x plus 12. Now I'm going to get that 12 out of here by subtracting it away. Now on the right, I'm going to have 2x, and on the left, I'm going to have negative 22. I don't want to know 2x, I want to know x. Come on, there. So I divide by 2 on both sides, and I'm going to end up with x equals negative 11. I can always, like with all of these problems, plug negative 11 in for x on both sides, and I'll find out that it does work. The problem does make sense. So that's the right answer. And that's it. No more slides. You're all set with the first semester problems, and if you've watched all these videos, then you should be all set for the final exam.